Hello everyone, my name is Ishwar and in this today's video I am going to show you how we can use the GDNTs in our parts. So without any further delay, let us get started. So for functional usability, I have taken one clamp and on this I kept some fastener over here. As you can see in this assembly, this part is going inside this base frame. So let me show you how it will go inside on it. So as you can see, this fastener will go inside here and it will going to tighten over here. So to get the functionality of this holes which is going inside this clamp, we need to use ZDNTs. So before this fastener will go this clamp, it has to go inside this plate. So for that purpose we are going to use ZDNT when we're doing our drawing or drafting of it. So this is a part which is going to assemble over here. So we will start drawing for this part in CATIA software. So as you can see, this clamp is individually shown in this interface of CATIA. So just maximize it, and now we will go for the drafting of this part. So go for mechanical design, select your drafting workbench, and here we will take our required size paper format, whether it would be a portrait or landscape, and the sheet size you can select over here. So for our users, A3 will be okay for us. So once done, just click over here. So this is the interface of CATIA, as you know. So first we will try to take the front view of it. So let us take this face, will be our front. Desired position and make it bit larger on. So I have used 2:1 scale. Yeah, hide this axis, we won't require it as of now. Okay, now we will take the another view of it. So this is the side view of that part. So once done, just right click and highlight your center line for your circle, and similarly for this side view or axis and center line. So once done, just pull the axis line and hide your axis, this one. Now take the dimension for this our rectangular part first, and thickness we can define here. Now to use the GD&Ts we need to restrict the three motions. Okay, and if you consider the negative axis also, then we have to restrict 6 degrees of freedom of this part. So for that one we are going to take this back face over one of the datums. So for that, just go to tolerance icon, and here we are going to apply flatness, and let us take its magnitude will be 0.1. That's it. So if you want to get some other kind of symbol shape, just right click and you can take or use it this kind of features. Now we took this back face as our one of the datum, and let us we will take this one as our A. Once it is done, so back face is one of the datum. Now since this part can be moved in vertical direction like this, so for that we are going to restrict the vertical motion by applying datums here. So take one more datum. If you are getting some issue while not able to keep your datums in vertical or horizontal direction, just use your control or shift key. So this time we are going to use perpendicularity, and its magnitude will be 0.1, and this surface is going to be perpendicular to surface A. And if you want to make it in horizontal direction, just right click, go to properties, and in the text make it horizontal. Once done, use your shift or control key to make it in desired direction. Once done, we will take this surface is our B datum. Right, now we have restrict the vertical motion of it. Now to move the horizontal direction or to restrict the horizontal movement, we need to take one more datum. So this face we will take as C datum. Before that we need to apply this tolerance box here, and this would be perpendicular to A and perpendicular to B. So till now what we have done, let me take to you or our 3D model. So this back face we took as C datum, and this face we took as B datum, right? So that if we'll take this one as B datum, that means this it won't going to move in vertical direction, right? Now at the last we took this one as C datum so that it can restrict the movement in horizontal direction like this. So now just go back to your drawing sheet, and now we will take the dimension for our holes. So this is our datum surface, so we can use it to take dimension from our reference surfaces. It could be a primary datum, secondary or tertiary. So yeah, one more thing I want to tell you guys. Once or when we applying GDNTs on our part, we need to use basic dimension of it. That means we can't apply tolerance in these dimensions. So for that you need to use a basic dimension to it. Now just extend the axis system so that anyone can understand this having sharing the same distances. Line up first. So if you want to take 10 or 12, it doesn't matter. So let me take 10 from this surface, and this one is also 12. For this surface also we will going to take 12. Oh, by mistake I took 14. Yes, and for this one we are also going to take 12. Now extend this vertical axis also. Now I was telling you that when we are using GDNTs, we need to use basic dimension. That means we need to keep the dimension in this rectangular box. That means we need to achieve this dimension only. Go to properties, done. Just right click, properties, done. Go to value, and here increase 3.5. This spacing of this dimension line to the outer edge of this rectangle. Now we took the basic dimension of it. Now we will take the diameter of this hole. Right click, properties, and go for dimension line. Here make it two parts so it will looks nice, since we need to keep tolerance box here. So once done, click on this tolerance box, and here we can apply our GDNTs. Here we will go for position, and this will be like 0.1, and references like, since we are making this hole in our A surface, so make it as A. Then from where you have taken these dimensions for these holes, either it could be BC or CA, anything. So for most of people are using alphabetically ordered, that means you need to follow the alphabetically sequence here. So we have B and C datums, so we will take here B, and later we will go for C surface. Now if you want, you can give the tolerance of this holes also by going in this top column, top row of this CATIA menu bar, and select any of the format, keep it 0.1, and so till now what we have done, let me summarize here. So to applying GD&Ts, we need to identify the surfaces from where we have to take the dimension of it. So first we took datum C, which is the back face of this part, and later we restricted the movement in horizontal and vertical direction by taking this B and C datums, and we started giving dimension from our datums only, and we have used these basic dimensions, and later we have applied this position tolerances. So this is how we can apply GD&Ts in the part, excuse me, and this is the most basic one, since it is a rectangular part and we have some holes. So we took only some of the datums and few many tolerances concept we have used here. So in my next video I am going to take one sheet metal parts, and where which having uneven surfaces, that means the edges are not be like 90-degree to each other. Sometime we will get some more inclination not than 90-degree. From there how we can define our datum, and how we will take the dimension for that holes on it. So in my next video definitely I'm going to show you how you can take the more datums, and let me take isometric view of it, so it will going to complete our drafting of it. If you want to rotate it, we need to keep 45 I think, and rotate it like this. Now we will take the isometric view of. Now go to our main assembly. So for this part we have done drafting of it, and we have also applied some of the GD&Ts and tolerance for these holes. So our functionality can be achieved when we are going to start using GD&Ts on the symbols. Since we have applied the GD&Ts, this fastener will be go inside easily, and it is going to help in getting our desired fit. So mostly for the fasteners we are going for the clearance feet, I'm sorry, it's like clearance fit, and in clearance fit the hole having a little bit more dimension or dia as compared to the diameter of this fastener pads. So let me show you my final set of this drafting here. So this one is a very pretty basic one, GD and this tolerance concept design. So in my next video definitely I'm going to show you how we can take more datums and how we can achieve more functionality of a part using the concept of GD and Ds. So thank you for watching this video guys.